This is Breaking Down Security. Hey everybody, welcome. We're doing a bit of an interview. Mr. Betcher is not here, unfortunately, due to time constraints. So what I wanted to do was we're doing a podcast today on content security policy. About a year ago, let me give you a little background. I went to a SANS AppSec in Austin, Texas, where I met Kevin Johnson and got my GWAP certification. And I saw a briefing from Robert Arsnake Hansen on content security policy and what you can do with that. And I was super intrigued. And, in my research on OWASP's website, I found somebody updated a wiki by the name of, I got it in my notes here, Pawel Krawczyk. Got it right. And we wanted to have him on the podcast to maybe discuss that. And he seems he does a lot with content security policy. And I welcome you, Pawel, to the podcast.
Hi, Brian.
While we're waiting for Mr. Betcher, if he does show up, I want to find out your origin story. Like many InfoSec superheroes, you all have an origin story. So I wanted to maybe see how you got to where you are today.
Yeah, so it all started with Amstrad Schneider computer back in late 80s. Then I went through FidoNet. Then I was a network administrator on the university, then started working for a local ISP and basically doing everything from network administration through the security testing. And then gradually went through all the stages, penetration testing, up to the high-level security management, risk analysis, doing things with compliance, a bit of business continuity and everything.
Was your need to start getting into information security out of necessity, or is it just something that attracted you from the get-go?
Well, taking into account that I started my adventure with computers, in the early 90s with a soft ties debugger, I think that security was there from the beginning. So it all just developed with time.
Nice. So it just kind of fell in your lap. You were doing IT, and then all of a sudden you saw a need for information security to be added to your bailiwick, and you went after it.
Yeah, exactly. That was the times where everything started, so it was really exciting.
Okay, so you've according to your LinkedIn here, you've done quite a bit of work. You're a consultant. You have been a consultant in the past. You've done some architecture work. You've done some training. You've been an instructor as well.
Yeah, I was. I mean, the Polish, because I come from Poland, the Polish info security market wasn't very big back then in 90s and early 2000s. So basically, you were getting a lot of requests from different companies and governmental organizations asking you to do all kind of weird things, starting from very low-level hands-on penetration testing of systems written in COBOL, up to some requests for consulting on electronic signature law, which in Europe is very complicated and typical legal thing. So obviously, to do that, you had to learn a bit of this, a bit of that, and this is how it all developed slowly.
Yeah, so you've worn a lot of hats and been all over the information security spectrum, which is nice to see. We like to have a well-rounded guest when they come on the podcast here. So your current job is an application security consultant for an organization over there in the UK. You live in Reading. I assume is the business in Reading as well?
No, the company is based all over UK. It's called Canis. It's developed software for public sector and private sector, and I mostly work on UK government projects.
Okay. And you do a little bit of IR, I see here, and helping people get up to ISO standards, which is very admirable.
Yes. I mean, this is one of the things that I do for Canis, but mostly I do everything related to security, basically from managing the security on the projects, teaching developers, advising developers how to do things securely, penetration testing, and also all the compliance work.
Oh, very cool. Of course, one of the things we wanted to mention is that you are here representing yourself and not your company. So any opinions, past, present, or future of your employers are not the opinions of your current employer, past, present, or future.
Yeah, I couldn't say this better.
No, that's okay. I just wanted to get that out of the way. I totally understand that anything we might say or I might bring up would, we don't want to put anything in a negative light for you there. So, all right. So let's get to the topic at hand. We're talking about content security policy, and maybe you could give us a little background as to how that came about. What was the need for it? How it came to be.
Yeah, absolutely. So content security policy is a really obvious thing once you see how this works. And it's basically, the idea has started a long time ago with things like X-frame options headers and all these small bits that allowed the website owners to tell the browser what kind of content is trusted, should be trusted. Because the browser is essentially very promiscuous in the origins of the content it will render. It will render anything that it will get from the web page, assuming that it's a legitimate content. Then it's not always the case, because if you have a website that is vulnerable, so for example with cross-site scripting, then the content will be served by the trusted server. It may be as well served over SSL, so it looks like it's completely trusted. Mm-hmm. But actual content that is sent to the browser is something that was made up by the malicious user. So it will not only load an untrusted JavaScript, but it can refer to external content, external pages hosting some, again, malicious code. So this is the whole motivation to introduce content security policy. It was basically to allow the website owner to declare a list of trusted sources that can be loaded. The simplest form is basically tells the browser, just trust the content that is loaded from myself, from the very page that you are loading this HTML from. Of course, you can expand it, and you can add whatever other domains that you are loading things from.
Okay, so this is very similar to same origin policy. So does content security policy only protect against cross-site scripting, or does that help against other web-based attacks? Like, would it work for CSRF, or would it work for, I don't know, any kind of XML-based attacks?
It really depends. I mean, in the case of CSRF, you obviously have the single origin policy, mm-hmm. And this would be probably the first line of defense in some cases. So essentially, the content security policy will block any attacks that require the browser to download something from external sources. So let's say, I mean, you can imagine a situation where you got some kind of attack that is used to steal session cookies or whatever, mm-hmm. Via image tags, for example. And in this case, if you have properly designed your content security policy, it will also block this type of attack, because it will prevent the browser from loading and external images from the untrusted domain. So yeah, it's not only limited to cross-site scripting. It's quite broad, especially in the latest version. the version 1.1.
Okay. All right. So you mentioned version 1.1. They're actually, what do they call it? You said they're calling it level 2 because there was an original version of CSP?
Yeah, there was version 1.0, and it's being implemented. I mean, it's a bit confusing, so maybe we don't go in very details into that.
Sure.
Because there were just to describe the complexity, there was three names for the CSP header out there that were actually implemented by browsers. Then each of the headers can be used in two variants, enforcement and read-only. So you got 6 headers at this moment. Then there was something we could call version 0.9 that was implemented by Mozilla, and it has different syntax from the version 1.0, which is now implemented by majority of the browsers. So
Okay.
Let's not go into all this, compatibility, backwards compatibility details, and let's just start from version 1.0 that is currently implemented by majority of browsers. And also, what is also worth mentioning is that I don't think we should also look at version 1.1 as something that is completely, new and distinct, because very large part of version 1.1 is already there in the browsers. So if you have latest Chrome, for example, it does implement large part 1.1 already. So it's the process of upgrading the standard is gradual, not made in steps.
Okay, so this sounds a lot like the browser wars that we had issues with, where web developers had to, basically build a website so that it worked well in all 3 browsers. Is this the same kind of issue that we have with CSP, where some things will work in Mozilla, some things will work in Chrome, but some things won't work in, say, IE or Safari?
Oh, no. I wouldn't compare this to the browser wars, where it was kind of intentional incompatibilities. In this case, I think the main motivation to create so many versions of the header and everything was basically that this technology was considered quite dangerous from the usability point of view. So most of the browser vendors didn't really want to introduce it in a finite way, so deliver a header and then just have it enforced. So they started from doing this in an experimental way. So the using those X something headers, the extension headers, incompatible with the other ones, was kind of a way of making sure that people will not get used to it too much before it gets stable. But now, as of 2015, I think we can speak about quite stable version of content security policy. There's one single header that should be used, which is called, content security policy, and that's it. So let's focus on this.
That's cool. Okay, so your whitelist, it almost sounds like it's a style sheet kind of thing. Is it an external file that is added to the browser, or is it inline to the HTTP? And where does it run when you load a page? Is it at the in the header section, or is it do you have to put that in the body of the? I mean, how does a content security policy get enabled?
So it's as it is with many HTTP security features, it's being set in HTTP headers. So it's not arriving in a HTML code, which may be already kind of tainted. It comes in the HTTP headers. And there is a very good reason to do this like that, because if you imagine the architecture of most web applications, the web application is basically some kind of engine framework that takes requests from the browsers and returns some kind of HTML with maybe input from a database or something like that. So it's a kind of closed entity, closed engine that processes data. It takes data and sends another processes data. Okay. And once this part gets compromised, you can't really trust it. So once you get evil data inside this closed system, whatever you add to HTML, it can be changed in the same way if the system is compromised. With HTTP, it's a bit different because typical web application will have a number of tiers before the actual web application server. So it can have a web application firewall, it can have load balancers, there will be actual web server, maybe some proxy or something like that. And you can set HTTP headers on any of these tiers, which means that you can have quite hardened and closed down proxy, let's say, in front of the actual application server, where you do set those security headers, and the likelihood that this part will get compromised, it's significantly lower than the chances of compromising the web application server.
Okay. Oh, that's quite interesting. So, you can also set specific policies by if you do. Can you make it so that, like, let's say you have a picture on the page. If somebody tries to load a malicious iframe or something with a picture, it would, along with the same origin policy. Could you make it so that it will only load certain pictures based on what you see on the site?
Yeah, absolutely. So the policy actually is a list of types of content. So there you get keywords like font SRC for font sources, web font sources. You get image SRC, frame SRC, and so on. So essentially, you can set a list of allowed sources, so URLs, for any of those types of content. So you can, for example, allow the page to load everything, any kind of content from self. So, well, if we are on example.com, any other type of content, so fonts, images, Flash files, Java applets can be loaded from example.com. But if you want to enable pictures to be loaded in addition to that from Flickr.com, for example, you just add Flickr.com to the image SRC keyword list. And that's it. It's really simple.
Yeah.
If you look on the actual header in live HTTP response, it's not very readable because it's usually very, very long string. But if you parse it, if you kind of pretty print it, it looks quite simple. It's just plain text. It's no XML, no JSON, just plain text.
So this is backwards compatible, right? If you're a website and for whatever reason you're not using HTML5, this will work with the older version of HTML as well. Is it just as interoperable?
Yes, absolutely, it is. So the interpretation of the tags. So if you get a tag, the content type you set, for example, is image, it will apply to all the image tags as the current browser understands it. But on the other hand, I don't think the compatibility is a big problem, because I believe if you compare the versions that support browser versions that support a CSP, I think majority of the versions will also support HTML5. So, I mean, we are speaking about pretty recent browsers.
That's cool. All right. So it works a lot like a whitelist. That's cool. How would this make your browsing? So this is like a server side, say, script safe or something like that. If you're using Chrome for a plugin, I use programs like script safe, disconnect, adblock. Well, I don't use adblock anymore. I use like uBlock or whatever. Will CSP make those kinds of plugins obsolete, or will there still be a need for those kinds of plugins to be allowed or to be used?
Yeah, the idea is a bit similar, but I don't think that CSP makes them obsolete, because essentially with CSP is a declaration of what the website author trusts. Yeah, so I can have a website with ads, and I will trust all kind of ad publishers, while yourself may not like to load those ads. So your NoScript extension will block those URLs. That's it. It's basically the final result that will be actually rendered and shown to you will be kind of a common set from those two.
Okay, so you can have, say, banners.adspace.com, and so the vulnerabilities could still exist if somebody was to hijack your ad network and input malware onto your site. You still have the possibility of injections because you as a web developer or a web application creator or content manager would still have external sites loading because you trust them, but you have to trust that those third parties are also trying to be as secure as possible.
Yeah, this is exactly correct. And unfortunately, CSP is not a silver bullet. So if you allow example.com, this means that you kind of can load anything that you allow will be loaded without any additional security checks. So if you allow example.com, it will be just loaded. If you allow scripts being loaded from example.com, the scripts will be fully trusted. Same for images, Java applets and so on. So that's it. It's not really preventing attacks if the remote content is compromised or malicious. There is a few features in CSP actually that do increase, we could say, a general security of the page rendering process. Essentially, I mean, this is also a reason why it's not so trivial to enable CSP on your website, especially if it's, it's been online for a while and it's got all kind of functionality. Because if you just enable CSP on your page, like this, there's chances are that a large part of your functionality will just go away, even if you allow everything from self to be loaded. So you allow images, script from the same domain, from the original domain to be loaded, because there's two functions that merely presence of the CSP header disables in browsers. Those two things are two features in JavaScript. One is inline code, so any kind of JavaScript code that you normally placed in script tags or in HTML is blocked.
Oh, wow.
It won't work. In the first place, it's the inline script that are blocked, and it applies equally to JavaScript and CSS, which is actually a big problem because having developed quite a lot of websites myself, I was never really able to develop a website that is not using some kind of inline content.
Sure.
Apart from very simple website that you develop from scratch, it's sufficient to use, let's say, jQuery, and immediately you will get some warnings about inline CSS or inline JavaScript being blocked. So the intention is very good here, because any inline JavaScript code can be identical to whatever is injected by a cross-site scripting attack. From the browser's point of view, the XSS attack vector is inline code. So this is the intention behind disabling any inline code. You can explicitly enable inline code in CSP header, which obviously will unblock all these features. Unfortunately, it will also result in bigger exposure to attacks. So this is one thing that is being blocked by default when you enable CSP. The second thing is eval function, which is, for those who don't know JavaScript very well, it's basically a function in JavaScript that executes text as JavaScript code,
Okay.
which is also quite dangerous. And you can also explicitly enable it. But again, this means that you are more exposed to attacks. There is another way to kind of the proper way to enable JavaScript that is located in line. It's by basically you can authorize the JavaScript blocks that you place in line for some reason using cryptographic hashes, which is pretty good thing. This is part of CSP 1.1 and it works pretty well. But again, this means that you have to kind of put some extra work into your page. And if you change even one character in the JavaScript code, you have to update the hashes.
Okay. So if somebody wanted to try to get around the content security policy, could they do things like, change some text or graphic to say encode in base 64, or I know that you use some things to get around WAFs. Would a lot of the stuff that worked for WAFs work also to get around content security policy? Because what I'm trying to do is do a little threat modeling here to figure out how I could bypass your security policies, because they're based on rules, right? So if you don't set everything properly, there should be a way to get around these.
It's not really based on your rules. It's based on origins. So you can, for example, declare that the trusted origin is, and it got different levels of granularity. So, for example, you could start from declaring the allowed origin to be data, which basically means that any kind of base 64 inline, data sources are allowed for images, for whatever, for JavaScript.
Okay.
You could allow just HTTPS origin, which basically means that any content that is loaded over SSL is trusted. And this is sometimes done to kind of enforce the pages loaded over SSL always only. But you can also go quite deep or being very granular, and you can put a whole precise, complete URL into the content security policy, which basically means that only this specific image or script or whatever will be loaded. So it's pretty flexible.
Okay. All right. So, this is something that's been created, like in conjunction with Mozilla and Google. And again, I hate to bring up the politics of the thing, but have the other major browser manufacturers gotten involved with helping to make sure that this is a universal kind of standard? And have there been any kind of political heat-ups by somebody wanting to only allow certain things in their browsers?
No, I wouldn't say that. I mean, I wasn't really heavily involved in the standards development process, but I was observing it at some point when I was contributing some bug fixes to the standards. Mm-hmm. And from what I have seen, there were no things like browser wars here. Sure. The development teams from all the vendors are involved. And every single browser now on the market either supports, I think all of them support CSP. The only difference is in the level of support. But mm-hmm. everyone kind of targets to support the whole CSP as much as possible.